This is a section on circles. So if you look at the top of your guided notes, it talks about writing the standard form of the equation of a circle, and it says the definition of a circle is a set of points in the xy plane that are a fixed distance that we call r from a fixed point hk. The fixed distance r is called the radius, and the fixed point hk is called the center of the circle. So let me do a little sketch here. If you had an xy plane like this, this would be the center, the point hk, and then this distance would be r, its radius. And that's a point, some point xy. So it says the standard form of the equation of a circle with radius r and center hk is x minus h squared plus y minus k squared equals r squared. You can see this if I want to try to find the length of the line segment that we call r. Then I would say that is a distance, and I can use the distance formula, and I can say if this is my x and 2, and this is my x1, y2, and y1, I can say it would be x minus h squared plus y minus k squared. And so then if I square both sides of that, if I square this side and I square this side, I get r squared equals x minus h squared plus y minus k squared, which is exactly what I just said right here is considered the standard form of the equation of a circle. Notice these are negatives, and the center is at hk, and then the radius is the square root of r squared. So it says the standard form of an equation of a circle of radius r whose center is at the origin. If I had a circle whose center was at the origin, then that means that the h and the k would be the point 0, 0. And so if I plug in a 0 for the h and a 0 for the k, what I get is this equation, x squared plus y squared equals r squared. And if the radius was equal to 1, you would have x squared plus y squared equals 1. And that special case where the radius is equal to 1 is called the unit circle, because the radius is 1 unit. Now, not all of them located, obviously, at the origin, with their center at the origin, have a radius of 1. But when it does, it's called the unit circle. So let's look at example 1. It says, write the standard form of the equation of the circle whose radius is 5 and whose center is -3, 6. Now you got to be careful here with signs. Remember, the equation is x minus h squared plus y minus k squared equals r squared. So we're going to go x minus, now look at h, here's the h, minus a -3 squared plus y minus, here's the k squared equals r squared. So let's clean that up, and we have x change plus 3 squared plus y minus 6 squared equals 25. And you leave it that way. You don't want to FOIL that out. There's no need to have to do that. All right? 2. It says to identify the center and the radius of each circle. So we know that's hk, and we know this is r. So we've got x minus 3 squared plus y minus 2 squared equals 25. So the center of that circle is the point 3, 2, right here, as long as there's minuses in front of it. Its radius is the square root of 25, which is 5. Let's look at the next one. We have x minus 3 squared plus y plus 1 squared equals 5. The center of it is 3, -1. So it's going to be the opposite of what you see, because in the formula, in And the equation is a subtraction sign. And the only way to get a positive is to subtract a negative. And then the radius is the square root of what you see, so square root of 5. And finally, we have x squared plus y plus 3 squared equals 9. Radius is easy. That's 3, square root of 9. This x has nothing added to it, so its center is 0. Here we have a plus, and remember the only way to get a plus is subtract a negative. So the center is at 0, negative 3. Alright, example 3 says sketch the graph of x squared plus y squared equals 4. Well, let's see what we know. The center, which is HK, is the point 0, 0. I know because there's nothing added to the x or the y. And the radius has a length of 2. So when you look at your coordinate grid there, it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Here's our center, and we know that its radius is 2, 2, 2, and 2. So what you try to do is just sketch that into a circle, and it's really hard to do, especially when my paper wasn't gridded. Mine looks like an oval, but yours, you ought to be able to do a little bit better job. That's all you do on one like that. It says now graph the equation using your graphing calculator. Well, how would you do that? X squared plus y squared equals 4. In order to put it into a graphing calculator, it has to be in y equals form. So we're going to have to do some rearranging here, and we get y squared equals 4 minus x squared. Take the square root of both sides, and you get y equals plus or minus radical 4 minus x squared. So how do you enter that in your graphing calculator? y1 is equal to positive square root of 4 minus x squared. And they may make you put parentheses there depending on your operating system. y2 is equal to negative square root of 4 minus x squared, probably in parentheses. That took care of my plus and my minus. And then you hit your zoom button, and you have to do zoom square, because if you don't, it's going to look like an oval because of the way the coordinate grid is set up. Alright, let's go to example 4. It says graph the equation x plus 3 squared plus y minus 2 squared equals 16. Well, what do we know from that? We know the center is the point negative 3, positive 2. Look right here. And we know the radius is the square root of 16, which is 4. So when you go to graph that, you're going to find the center, which is at the point negative 3, positive 2. So it's right here. And the radius is 4 long. So we have to count over 1, 2, 3, 4. So you would have that point. And then you have to count up from here 4. 1, 2, 3, 4. Again, mine isn't going to look like a circle because my grid isn't marked correctly, but yours can. You would count over to here, and then you would count down 1, 2, 3, 4. And then we would turn that into a circle on the sketch. Try it on your grid. Mine, again, looks like an oval because of the way I drew it. But on your coordinate grid, you should be able to draw that just from this information. Now, how do you graph this in a calculator? Let's talk about that. That would mean I have to take the equation x plus 3 squared plus y minus 2 squared equals 16, and I'd have to solve that for y. A little bit harder than the last one. So we would first subtract an x plus 3 squared from both sides, and you would get y minus 2 squared equals 16 minus, parentheses, x plus 3 squared. Then you'd have to take the square root of both sides, and you get y minus 2 equals the square root of 16 minus x plus 3 squared, and that's a plus or minus. And then we added 2 to both sides, and let's look at what we have. We would have y1 would be a 2 plus square root of 16 minus x plus 3 squared. And y2 would be a 2 minus square root of 16 minus x plus 3 squared. Put that in your graphing calculator. You'll see a much better graph than what you have, but what you're going to see is part of it graphs the top half, and then this negative piece will graph this bottom piece, although it will look circular. And then always zoom